test it for real. Here at NASA's Vertical Gun Range, they're recreating that ancient collision in a laboratory. This 9-meter-long gun fires a tiny projectile at 29,000 kilometers per hour. The projectile is Thea. This ball represents the Earth. By changing the angle of Thea's impact, the team can work out how precise the ancient collision had to be in order to make the moon. In the first shot, Thea hits the top of the Earth with a glancing blow.
So here's the Earth, if you will, just suspended in space, and now it's gotten hit. So now we see the planet, the ejecta, is being ripped out of the Earth and is forming this giant impact basin. And if this really were the Earth, this basin would be thousands of kilometers, thousands of miles across.
In this simulation, Thea only skims off the surface of the planet, and very little debris is thrown out into space. Not nearly enough to build our moon. The second shot is a head-on collision.
Pow! That's the end of planet Earth. It's gone. Some of the debris is going to go out of the solar system. Some of the debris will reaccrete to form small planetesimals within the solar system.
There's no Earth left, so there's no gravity to gather the debris and form the moon. Now the gun is set to just the right angle, halfway between a glancing blow and a direct hit.
So we'll see what happens if the Earth barely survives. Oh, gorgeous! Oh my gosh! Kapow! Now we have the entire part of the Earth being ripped apart, but the vapor plume is, oh my gosh! Jeez! That is gorgeous. But this was the beginning of our moon.
The experiment shows that Thea could have smashed into the Earth and formed a moon. But the collision had to be just right. And, fortunately for us, it was. Today, the moon's orbit is 363,300 kilometers from Earth at its closest point. But when it first formed, the moon orbited just 24,000 kilometers above the Earth's surface.
500 million years after the moon formed, if we looked up in the sky, the moon would have comprised a tremendous portion of the sky. It would have been enormous because the moon would have been much closer.
At that point in time, the Earth was rotating so fast, a day lasted just 6 hours. But the moon was so close, its gravity acted like a brake. It slowed our planet down, until a day now lasts 24 hours. The moon's gravity also created giant tides that surged across the planet, churning up the seas, mixing minerals and nutrients. This created the primordial soup from which the first forms of life arose. Without our moon, life on Earth may never have happened. And there may be other moons with a link to life as well. Moons may be the great biology experiments of the universe, the true laboratories of life itself. Moons are full of surprises. There are moons with giant volcanoes, moons with vast oceans sealed under thick ice, And now we know a few are rich in organic compounds. In the right combination, they might even support life.
In our solar system, the biological window through which we can understand the rest of the universe may be through these moons of the outer solar system. That may be where we find our second genesis. And that second genesis is really our first deep understanding of the biological nature of the universe.
At first sight, moons don't appear ideal for life. But on our planet, life has shown it can survive in the harshest of environments. There are creatures on Earth that survive in extreme cold, searing heat, and even in the deepest, darkest ocean trenches. They're called extremophiles.
By studying the extremophiles on Earth and understanding just what are the boundaries of life, what is the envelope of environmental conditions within which life really can survive, then we have a basis for extrapolating to these other worlds.
And there are moons that could be as hospitable to life as any of the extreme environments on Earth. Take Enceladus. It's a shiny ball of ice, 480 kilometers across, orbiting Saturn.
It's the brightest object in the solar system. It reflects 100% of the light that hits it, so it's super bright, and that's because it's water ice.
In 2005, the Cassini probe observed ice volcanoes erupting from the surface of Enceladus. That meant there had to be heat under the ice. Heat that created oceans of water. And where there's water, there's the possibility of life.
So this is Beehive Geyser here in Yellowstone, and it is shooting water vapor and water about 150 feet into the sky, and it's pretty incredible. So now imagine if you're on the surface of Enceladus. You would see geysers that look a lot like this, and they are shooting ice grains and water vapor into space thousands of times higher than this geyser here.
The ice volcanoes are powered by gravity, and this is how. Saturn's gravity works on the core of the moon, heating it up. The underground water expands and forces its way up through cracks in the surface ice and blasts out into space as ice crystals. These are some of the most spectacular eruptions in our solar system. They make Beehive Geyser look like a water pistol. From the ice in the volcanoes, scientists have detected salt and simple organic compounds. That means the water under the ice is not only warm, but full of nutrients. Heat, water, and nutrients. That's how life on Earth began.
We realize you could have all the things that we associate with oceans on the Earth going on inside a moon. It's the discovery of a lifetime.
Saturn's Enceladus has an ocean. So does Jupiter's Europa. But these aren't the only moons where life could emerge. Saturn has another moon, Titan, with an even greater potential for life. In 2005, Cassini sent a probe named Huygens on a one-way mission to Titan. For just 3.5 hours, Huygens transmitted live pictures from the hostile surface, over 1.5 billion kilometers away. But then it ran out of power.
It was just incredible. This was the first time humans had ever touched this moon with something of our own making. It was just an event that should have been celebrated the world over. We should have had ticker tape parades in every major city across the US and Europe to celebrate this. It was that history-making and that astonishing.
Raindrops on Titan are twice as big as raindrops on Earth. But the rain isn't water, it's methane. On Earth, methane is a gas. But on Titan, it's a liquid because the moon is so cold.
There may be methane icebergs, there's certainly methane lakes and rivers, and there's methane rain and methane clouds, and maybe bugs swimming in methane.
Bugs living in liquid methane may sound unbelievable. But scientists have discovered that Enceladus, Europa, and Titan are all covered with a substance called tholin. Tholin contains the chemical building blocks for life to begin. Could life emerge on any or all of these moons? We can't obtain any of the tholin from the moons, but Chris Mackay makes it in the laboratory. He zaps a mixture of gases found on Titan with electricity. What he gets is a reddish-brown material.
So this is what we make, tholin, this sort of non-biological organic material. It's produced by chemical energy put into simple molecules like methane and nitrogen, and here we got it. And that's the material we see on Titan. We see evidence for something like this on Enceladus. We see it on the surface of many of the moons in the outer solar system. This is nature's recipe for making the stuff that life eventually emerges from.
Somewhere in the outer reaches of our solar system, on some remote moon, life may have already emerged. But it probably won't be life as we know it.
Life 2.0 doesn't necessarily have to have the same genetics as life 1.0, right? In fact, the more different it is, the more interesting it is.
Whether it's the same or very different, the discovery of life on the moons of our solar system will change the way we look at the universe.
I think that should we ever find that life had originated not once but twice in our solar system, then you can easily dismiss any arguments that say that life is unique to the Earth.
Moons are small, but they're still diverse and dynamic worlds. They help us understand how the universe works. They're an essential part of the cosmic machine. Without any moons, our solar system would be a very different place. And without our moon, life may never have evolved on Earth. And who knows, when and if we find new life somewhere else in the universe, its home may not be another planet at all. It might be a moon.